Right. Okay. So here we go. I have shared the screen. Yes, I have. Let's discuss. So what we're discussing is um, the different kinds of processors. It's again an elaborated version of your P1. So you are aware of the instruction set in a computer. You know what an opcode is and what an operand is. So opcode is obviously a command that you will be giving, and that command will be given to either the data or it will be given to the address where that particular data is, right? So we already know about it. The instructions specifically are in ones and zeros, they're in machine language. So how are these instructions catered for? इसकी हम बात करेंगे. So yes, the standard format for the instruction is that you have the opcode and you have the operand address. The to address means that you have the opcode and it refers to two particular addresses. And three address means obviously you have the opcode and you have three operands where you are specifically referring to. Is that clear? Right? So in case if they ask you about two address opcode or three address opcode, it's a quite basic thing, I think. So we should be able to address. This is something that obviously you have done before. Okay, assembly language, right? Generally, we have two categories of instruction set which are used in computers and devices. The first one is your RISC, reduced instruction set computer. Now, please confuse mat hona. Reduced instruction doesn't actually mean that there will be less number of instructions. There's a lot of confusion in many platforms के बारे में. वैसे मैं आपको बताता हूँ कि जो RISC यूज होता है ये आता है आपके फोन्स में, okay? Because this does not work more on hardware. So the concept of RISC involves an attempt to reduce the execution time by simplifying the instruction set of computers. So RISC will mostly emphasize on what? It will reduce the execution time by simplifying the instruction. So this is the key word, simplifying the instruction. So generally when we talk about the reduced instruction, हमारा actually मतलब होता है simplifying the instruction to reduce it. Okay, the other form, which is the complex, it is actually complex. This one is not complex. In other words, it's simplified version. You catch my point? Okay, but if you look at the example, you would see in case of a RISC, you would need more commands. Then you might be saying, sir, इसमें तो commands ज़्यादा आ रही हैं, तो ये reduced instruction किस तरह है? It's just that those commands are more simplified as compared to CISC, which is a complex instruction. One particular command is too much complex that it requires multiple cycles for it to be executed. इसके केस में add में सिर्फ add में एक cycle, load में एक cycle. So okay, delete में one cycle. You don't need lots of cycles. This is why जो CISC होता है ना, वो हमारे phones में use नहीं होता, क्योंकि इतनी cycles आपका phone नहीं कर सकता. It will obviously require a lot more energy and it will generate a lot of heat as well. Okay, आपका जो है complex instruction set computer है, the other one. हम दोनों को डिटेल में डिस्कस कर रहे हैं, no worries. So one of the most important feature about RISC is to execute one instruction per clock cycle. Okay, it's one of the most important. Okay, this is done by overlapping the fetch, decode, and executed phases. Okay, which are also actually referred to as a procedure known as pipelining. It's a very good important topic, what pipelining is and how does pipelining work. We'll just talk about that. Okay. Should I proceed? Right. So what is pipelining? So obviously pipelining is a technique where we have multiple instructions that can overlap. So this means pipelining will be implemented when you have multiple instructions that can overlap. If I don't have multiple instructions that can overlap, I cannot implement pipeline. And you know why I'm emphasizing on this fact? क्योंकि जो CISC है, उसमें pipelining का implement नहीं कर सकते, उसमें possible नहीं है. So let's look at a form कि pipelining basically होती है. Pipelining obviously होती है कि एक set of fetch execute करोगे, फिर अगले करोगे, फिर अगले करोगे to save time. So look over here. Let's directly look over here. if you look at this particular example, जो typically हम use करते हैं laundry analogy में, जिसमें we have over here, let's say we have washed, we have dried, and we fold. Wash, dry, fold. So we go through this, then we do this, then we do this, then we do this. So obviously this is going to take a lot more time to execute these four. Fine, obviously, just an example. What if we convert this into this form? So we can reduce the time a lot. What's happening is we have actually overlapped this. So once we are done with this, okay, laundry में डालेंगे, हम उसको इसमें यहाँ start कर लेंगे. So we'll start right away. So those stages overlap हो रही हैं every time because they can be done. Okay, while you start doing this, you can start the other one. Then you can start the other one. Then you can start the other one. You reduce a lot of time. Okay, so obviously it's a smarter approach to the problem would be to put in second load of the dirty laundry into washer after the first one was already clean. Right, so obviously आप उसको compress कर रहे हो and fetch execute को आप overlap कर रहे हो. Right, get my point? This is known as pipelining concept. अभी हम डिस्कस करेंगे आगे जाके कि why is it कि जो CISC processors होते हैं उसमें पाइपलाइनिंग क्यों नहीं हो सकती? Then it will be more clear. Okay, should I proceed further? Pipeline. Okay, let's talk about RISC and CISC now more detail. We'll keep on. Obviously, this is a part of the von Neumann architecture that you studied in AS level. ठीक है, ये उसी के basis पे आता है सारा, right? There are two basic philosophies that have merged over these years. पहली जो है उसमें developers who want to emphasize on the hardware. दूसरा ये developers who want to emphasize on the software. मतलब the instruction set to be used. There are some people who want to actually invest a lot on the hardware. Okay. But some might say, okay, fine, we can just normally invest on the hardware. Let's try to make the code more efficient. If we try to make the code more efficient, the instruction set more efficient, probably हम इसको और fast execute कर सकते हैं. And they're right. This is why हम ना तो CISC ना तो RISC दोनों ही use हो रहे हैं. RISC हम phones में use कर रहे हैं, CISC हम laptops, multiprocessing systems में use कर रहे हैं. ठीक है? So let's see how do we talk about both of them. Let's talk about RISC first. So again, a repetition of what I said before. RISC processors use smaller set of simple instructions which make them easier to decode and execute quickly. Okay. Obviously, if you're able to do this faster, आपकी execution faster होगी. Right? Complex on the other hand, क्या होता है? The main idea is that a single instruction will do all load. Now look at this. The main idea is that a single instruction will do all loading, evaluating, and storing operation, just like multiplication command will do stuff like loading and all that. So हम totally rely करेंगे एक command पे. Just one command. Okay. So will this work? Let's see. इसको अब आगे के details में discuss करते हैं एक property इनकी RISC and CISC की to clarify what it is. Okay. Right. मैं बल्कि आगे चला जाता हूँ. Features of RISC. So RISC को पहले discuss करते हैं. Simple instructions. Okay. Obviously. आपने तो आपने लिख लिया है. Instructions comes under size of one word, just like add होता है आपका, load होता है. There's just one word is used, so it's very simple. And a RISC processor will obviously execute one action per instruction. Okay, taking just one cycle to complete. Okay, so again, instruction is minimum. Instruction goes one cycle to complete. Okay. Then more general purpose registers are used over here. Okay. Achha, more general purpose registers are used. Why would we need more general purpose registers? Because listen, if I have just one particular command, probably it will require lesser space. अगर registers की बात कर रहे हैं, I am not talking about how much execution time उसका कितना लगेगा. हाँ, मानता हूँ complex instruction को cycles ज़्यादा चाहिए होंगे. मगर स्टोरेज स्पेस तो उसका कम होगी ना. In case of this, you would need so many multiple commands. उनको स्पेस भी ज्यादा चाहिए होगी, रैम भी ज्यादा चाहिए होगी. इसलिए आपके जो फोन्स होते हैं उनमें जितनी रैम बेहतर होगी, they work more efficiently. Okay, they require more RAM. So this is why we need more general purpose registers. There's more requirement of it. So the emphasis over here is more. Okay. Technically, we call it RAM as well. Okay, हम उसको RAM भी कहते हैं. We need more RAM. Simple addressing modes, not complicated. Just have to fetch from one address and send it somewhere else. It's not complex. Again, the contrary of this, it's very simple. It has simple addressing modes, not very complicated, and fewer data types are used as well. A pipeline can be achieved in case of RISC. ये हमने भी पहले discuss कर लिया. Okay, CISC में नहीं होगा, इसमें pipeline can be achieved. Okay. Advantages, well, obviously, RISC processors perform better due to being simple, and you have a limited number of instruction set. Fine. Okay. So since your instructions tend to be simple, the performance is good, right? RISC processors tend to have few instructions, then CISC processor makes them less expensive as well. Few transistors. So RISC processors tend to have fewer transistors. Your CISC processors have more transistors. So obviously the cost goes down. And why do we need to have less transistors in a RISC? Because initially when we started the lecture, हमने discuss किया था कि RISC क्या होता है? It's more on the software dependent. It's more about your instruction dependent. So since it's more dependent on the instructions, we try to implement less hardware. In CISC, we try to emphasize more on the hardware. In CISC, we try to less emphasize on the instructions. CISC में ही करते हैं ना हम. इसलिए हम एक ही कमांड देना चाहते हैं और चाहते हैं उसी कमांड से वो करें. ओके, सो ऑब्वियसली वो फिर कॉम्प्लेक्स हो जाता है. मगर उसके CISC के केस में फिर हार्डवेयर को ज्यादा काम करना पड़ता है, वो हीटअप ज्यादा होता है. ओके, राइट. इसलिए आपके फोन ज्यादा यूज करें, आपके फोन के प्रोसेसर इतने ज्यादा गर्म नहीं होते एज कम्पेयर टू योर लैपटॉप. But obviously, the type of processing they do, they're meant for it. Right. Okay. CISC allows instruction to use free space on microprocessor because of simplicity. It can complete its work in one cycle. Obviously, I mean, जब आपका एक ही command जाएगी, एक instruction जाएगी और फिर वो execute होती रहेगी बार-बार, so it will be able to free up faster. So since it will be performing faster, better, you will be having more free space. So the first point leads to the third point. It's directly proportional. Get my point? It does. RISC processor is simpler than CISC because of its quick design and it can complete its work in one cycle. Way point was frankly speaking. A disadvantage. These are the important things. A notable drawback of RISC is that the performance of the processor depends on the programmer or software developer. क्या मतलब इस पॉइंट को? ईमान elaborate करो. We just talked about it, didn't we? Zainab? Hana? So what do I mean by this statement?
It's software dependent है, तो जो भी programmer होगा उसको coding वगैरह करनी पड़ेगी, तो it
Depends on that, exactly.
He will have to make sure कि वो सारी coding वगैरह सही होता है.
Exactly. And the same point, if we talk about CISC, we will criticize the hardware developer. Hardware architecture, वो अच्छा डिजाइन नहीं होगा या अच्छा होगा तो उस पर डिपेंडेंट होगा. Absolutely. And then the second disadvantage that we have is the simplicity of a processor based on the reduced instruction set computer puts a lot of stress on software application. Obviously, I mean, I'm just trying to elaborate the first point into a different disadvantage. If we somehow do it we will be putting a lot of stress on the software and application, and which can lead to it fail at times. Yes or no? So it has to be designed in such a way that it does not uh, fail, and a lot of stress is not on the software end and the application end. Okay, better you following? Huh? Sure. Okay. Right. Then we have is more instructions required. Obviously, RISC processors require more instructions to perform complex tasks than processors. Obviously, more instructions are required. Now, you might be saying, sir, अभी तो आप कह रहे थे इसका मतलब है reduce instruction. More instruction का मतलब है they're simpler. They're simple instructions. Okay. Okay. But they tend to be in more amount. Okay. So reduced actually मतलब होता है the complexity has been reduced. You catch my point. This is one of the ambiguity that happens with many students कि reduce की बात कर रहे हैं मगर आप साथ ही कह रहे हैं कि commands भी ज्यादा हैं. नहीं, commands की बात नहीं कर रहे, हम उनकी simplicity की बात कर रहे हैं. Okay, कि वो simple हो जाता है. Get my point? Complex होती है. RISC processors need to save various instructions quickly, which necessitates obviously the cache memory to set up correct. Obviously, so this processor need to save various instructions quickly, which necessitates a large cache memory set to react to the instructions in the timely manner. Okay, so same way जो मैंने एक advantage कहा था, ये another disadvantage भी बन रहा है. In what sense? What do I mean by this point? Can you make it up? आइडिया समझाइए.
सर वो आपने कहा था कि randomly लॉजिक पे ये होती है
हम्म.
तो लेकिन के लिए खास और एग्जीक्यूट जल्दी से कर रहा है लेकिन उसमें मेमोरी जो सॉफ्टवेयर है उसको बहुत ज़्यादा मेमोरी होल्ड करनी चाहिए.
Absolutely, because देखो simpler instructions तो हैं मगर the quantity of the simple instructions ज्यादा होगी ना, तो जो simple instruction की quantity ज्यादा आ रही है उनको timely manner पे मैंने कैशे से उठा के fetch execute करना है कि नहीं करना. If I timely manner पे अगर मैं उसको नहीं कर सकता, that could be an issue. उसकी बात हो रही. You catch my point? This is what we are referring to. काफी indirectly मगर बहुत valid point है. ईमान को समझ आइए बेटा? Are you sure? चलो आगे. Okay. Then we have a CISC. So obviously, the term CISC stands for complex instruction. It's a CPU design plan based on single commands, which are skilled in executing. They are single commands, but they tend to be complex. That's the first thing. So you have complex commands. Okay. So these commands would take long time to perform. They would need several cycles for every separate instruction to take place, unlike the previous one where one cycle was required. Okay. In CISC, instruction pipelining is not easily implemented. Why would that so? Why would this happen? I mean, why can't we implement CISC instruction pipeline? Not why? क्या ख्याल है? Overlap भी नहीं करता और हर different instruction will take different cycles and we exact overlap नहीं करेगा. You're right. We wouldn't know कि वो exactly कर रहा है. उसमें तो हम कर सकते हैं. इसमें तो हमें नहीं पता ना. क्योंकि fetch execute decode में हमें idea नहीं होगा ना. They might take more time. Overlap proper नहीं करेंगे. हमको किस तरह arrange करेंगे? It wouldn't use pipeline. So features of CISC basically, the length of code is short, so it requires little RAM. Fine, good. The very first thing. It's actually an advantage as well. Feature भी, advantage भी है, property भी है. Another property is that आप लिख चुके हो पहले वैसे तो they may take longer time than one cycle to execute, so they need multiple cycles to obey one particular instruction. One is not enough. कौन सा? नहीं, फॉर एग्जाम्पल इसमें जो ऐड है ना, इसमें हम सिंपल लिखते हैं ऐड दिस, तो जो टेक्निकली जो लेंथ होती है ना कोड की, इसमें शॉर्ट ही होती है, द लेंथ इज शॉर्ट, बट इन ऑर्डर टू एग्जीक्यूट दैट सिंपल ऐड यू नीड टू डू सो मेनी थिंग्स. जिस तरह मल्टीप्लाई होता है, मल्टीप्लाई से पहले आपने दो वेरिएबल्स को लेना है, उसके बाद आपने उनको जिसमें डालना है, फिर आपने उनको मल्टीप्लाई करना है. देयर आर लॉट्स ऑफ अदर थिंग्स यू हैव टू डू बिफोर दैट. लेंथ कोड की शॉर्ट होती है, बट प्रोसेसिंग टाइम उसकी बहुत ज्यादा होता है, कॉम्प्लेक्स होता है. फॉर एग्जाम्पल बात सुनो, जो रिड्यूस इंस्ट्रक्शन है ना, उसमें मैं करूंगा लोड ए, लोड बी, ओके, फिर मैं ए बी को मल्टीप्लाई करूंगा और फिर आउटपुट दे दूंगा. इसमें ऐसा नहीं होगा, इसमें ए की कमांड होगी मल्टीप्लाई ए बी. इट हैज टू फिगर आउट इटसेल्फ उसने किस तरह करना है, जस्ट बाय वन कमांड. इट विल नॉट यूज मल्टीपल. दिस वन सिंपल एग्जांपल, मगर इट्स लॉट मोर कॉम्प्लेक्स होती है इसमें, राइट. बट इसमें ऑब्वियसली अगर मैं मल्टी या MULT, that word तो छोटा है ना, so takes less RAM. Okay, the command actually assembly language है ना, तो assembly language में these जो आपके opcode होते हैं उनको देखा जाता है ना, वो कितनी स्पेस ले रहे हैं. Every character counts, so we're referring to the opcode की length. This is the opcode. Less instructions needed to write an application. Yeah, obviously, I mean for जो really good assembly language programmers होते हैं, उनके लिए तो CISC प्रोसेसर के लिए लिखना टाइम सेविंग ही है ना. as compared to someone who works for the RISC processor, they have to type multiple instructions to do something. ये आराम से कर लेंगे. But obviously इसमें आपका हार्डवेयर बेहतर है, उसमें हार्डवेयर बेहतर नहीं है. वहां आपको कोड को ऑप्टिमाइज करना है या अपने हार्डवेयर को ऑप्टिमाइज करना है, मगर आप प्रेशर डाल रहे हो कोड पे. वाइस वर्सा है ना, डिपेंड करता है आपको चीज कैसी चाहिए. यस और नो. मैं एक फोन में तो आई कांट हैव अ लॉट ऑफ कॉम्प्लेक्स हार्डवेयर. फोन हीट अप होगा, बैटरी लेगा, ठीक है, एंड इट विल बी हैवी बल्की एज वेल, सो आई हैव टू यूज रिस्क. मगर लैपटॉप या कंप्यूटर्स में आई कैन डिपेंड ऑन सिस्क. सो इट डिपेंड्स ऑन वेयर यू यूजिंग इट technically. Okay, it provides easy programming in assembly language. Yeah, obviously I just told you, explained it, easier for the programmer to work. Support for complex data structures and easy compilation at high level language. वही उसी frankly उसी का elaborate मैंने example को देख किया. It is composed of few registers and more addressing nodes, typically 5 to. So yeah, remember we just talked about the RISC where we need is more registers. Here we need few. Yes or no? Right? Instruction can be large, one word, emphasize it will. Yeah. 8 point वैसे मैंने डिस्कस कर ही लिया है. Right. Features, let me see. So complex instruction takes more than a single clock. आप लिख चुके हो. It provides easy programming. Fine. Advantages. I सब सुन लो. You have written it down. It is less expensive than hardware. Yes or no? Okay. Micro:bit something easier to implement. Code is quite short. To store मैं कोई नया point तो नहीं है. Less RAM, fine. Execution collection several low tasks. Creates process manage low power. It uses few instructions set to perform same as RISC. और few instructions होंगी. Disadvantage देख लेते हैं, ज़्यादा important है. CISC chips are slower than RISC chips to execute per instruction per cycle each program. Okay, right? Generally per instruction cycle than each program. क्या मतलब? Why per instruction का क्यों होगा? Indirectly आप कह लो, क्योंकि जो आपका risk होते हैं ना, they are dealing with just one particular command. So risk tend to be faster. The CISC होते हैं, they will be slower because they are dealing with more data, more complex commands. So ultimately तो slower होंगे, यूं कह लो. So as far as the instruction is concerned, the instruction cycle is concerned, the performance is this way. Overall, तो yes, CISC are faster. बिल्कुल, उसको खुद फिगर आउट करता है. एग्जैक्टली. इसलिए उसको मल्टीपल साइकिल्स चाहिए होंगे उसके लिए, और मल्टीपल साइकिल पे टाइम लेंगे. That's what we're trying to say. To execute per instructions on each program. The performance of the machine decreases due to the slowness of the clock speed. Obviously, clock speed. और आपको पता है, अब कंप्यूटर्स में जाके, पता नहीं, अब तो मैं ट्राई नहीं किया, लाइक 10 years बैक जब पेंटियम थे, यू कुड हैव इंक्रीज द क्लॉक स्पीड ऑफ द प्रोसेसर. जो भी क्लॉक स्पीड है, उसके बायस में जाके यू कुड इंक्रीज इट. मगर अल्टीमेटली दिस रिजल्टेड इन प्रोसेसर्स बीइंग बर्न्ड आउट एज वेल. क्योंकि आप अगर उसको डबल स्पीड पे कर देते हो, तो उसका जो what you call it, the heat sink है, it's unable to dissipate the heat so fast. So it resulted in the processor being burned down. हुआ था ऐसा. फिर उन्होंने एक्चुअली उसको कहते हैं ओवरक्लॉक. द ओवरक्लॉक, यू कांट डू ओवरक्लॉकिंग नाउ. मुझे एग्जैक्टली नहीं पता आजकल कर सकते हैं, मगर मैंने आज सुना ही लोगों को ओवरक्लॉकिंग करते हुए, मगर करनी नहीं चाहिए. एंड वेन एवर यू बाय रिफर्बिश कंप्यूटर्स, ज्यादातर उन्होंने ये भी किया होता है, रिप्रोग्राम ओवरक्लॉक भी किया होता है. सो यू शुड एक्चुअली नो, गो टू द वेबसाइट एंड फाइंड आउट कि जो प्रोसेसर है उसकी क्लॉक स्पीड क्या है, और जाके उसके बायस में चेक करो क्लॉक स्पीड वही है कि नहीं है, किसी ने ओवरक्लॉक तो नहीं किया हुआ. क्योंकि वो हो सकता है आप जब यूज करिए तो बड़ा फास्ट है, मगर इवेंचुअली व्हेन यू यूज इट फॉर हाफ एन आवर, वो इतना हीट अप हो जाएगा, इट विल बर्न अवे. क्योंकि आप तो जबरदस्ती क्लॉक स्पीड तेज कर रहे हो ना, वो तो फिर इट वोंट वर्क. ओके, दिस इज व्हाट वी आर रेफरिंग टू. Executing the pipeline in the CISC processor makes it complicated to use. Okay, so I mean, you can't implement pipeline in simple words. Yes, the CISC chips require more transistors as compared to RISC. I think so. We know that. In CISC, it uses 20% instructions in the programming event. Yes, so CISC uses very less instructions in a programming event. So somehow, I mean, we are not utilizing the full commands instruction that we should be using. We're just using very limited one. So anyway, it's a disadvantage for the programmer point of view. Get the point? Maybe I want to do something which or ye hota hai for assemblers, which is not available in a CISC assembly language. So what do I do? Can I use commands from a RISC? That's a question mark. I can't all the time. Okay, so fewer instructions can lead to a problem in programming it. Okay, Zafir, volume down. Your volume. Shh. Okay. So read this. Can you read this? Use it in laptops. Using smartphone tablets. Has more complex hardware. Has simple hardware. Large number of complex instructions. Smaller. Multiple. Single. Physically large, physically small, greater energy consumption, lower energy consumption, yes or no? I think that this explains it a lot. Can't make user pipeline, can use, emphasis on hardware, emphasis on software, small code, large code, makes more efficient, heavy use of RAM, multiple addressing modes, fewer addressing modes. So I think so. You have lots of points in over here. Or yahi question typically you get in the exam where you have to write two points of each. और कंपेयर, दैट्स इट. ऐसा ही क्वेश्चन नहीं आता है. काफी इसमें पॉइंट्स है, ज्यादा जरूरत नहीं है हमें. राइट? एनी पॉइंट यू वांट मी टू एलैबोरेट ओवर हियर? आई थिंक सो वी हैव डिस्कस्ड ऑल दिस. करें डिस्कस आगे. अब लेट मी गो टू द बुक. बुक में एक और चीज रहती है जो मैंने यहाँ डिस्कस नहीं की हुई, व्हिच वाज समहाउ आई शुड हैव एडेड इट. या ओके, नो, वेयर इज द बुक? वेयर इज द बुक? किधर है ये चैप्टर था हमारा? Okay, hardware. So risk pipelining. Okay, now let's talk about different kinds. There are more kinds. Okay, so we have parallel processing systems. So the first one that we have uh, is single instruction and single data. So you have a single instruction coming in, and you have a processor that can only handle that instruction. This was basically used in the old computers. Jisme multi-threading was not very common, just like T1. Okay, very initial computers that you had. So you just have a single instruction and you're processing the single data. That's it. Personal computers initially is basis pe kaam karte the. Then you have, is it fine? Then you have single instruction on multiple data. What could this be? You have a single instruction coming in, but multiple data pe ho rahe. For example, this one, data source and multiple processors. This is where your enhanced graphical user interface came into existence, because आपने हर pixel को separately process करना था. Okay, so graphic cards, basic जो graphic cards होते हैं वो इस processor को use करते हैं. Single instruction on multiple data. Okay. देखो, let me read this out to clarify हो जाए. SMID are often referred to as array processors. They have a particular application in graphic cards. Yes. For example, suppose the brightness of an image made up of 400 pixels needs to be increased. Since SIMD can work on many data items at the same time. So I want to increase the brightness of all the 400 pixels. Okay. 400 small processors, one per pixel. Each can alter the brightness of each image by the same amount at the same time. Yes or no? So when you're increasing the brightness for 4,000 pixels at the same time, what's happening at the back? This is happening at the back. So your data source individually is being processed individually. हर pixel की individually cater हो रही है. Is this clear? Yeah. So you have single instruction on multiple data. What is a single instruction? To increase the brightness. But where is it implemented? On multiple pixels. Yes or no? Fine. Then you have this multiple instruction on single data. So multiple instruction on single data. Why would you need this? Why would you need such powerful thing? कि multiple instructions सिर्फ एक data पे हो. Why just one instruction or one data पे क्यों नहीं बता? For accuracy of results. Okay. So I need to have as much accuracy, as much refinement on my data. So एक ही data पे मैं multiple processes करूंगा. Okay. Instruction और ठीक है. In that case, you have this. So ये basically use होता है आपके space shuttle program में, where the chances of errors are minimum. आप errors नहीं कर सकते. You can't do it. You catch the point. Obviously, it's not a commonly used architecture. It's very rarely used, but obviously we need to discuss it. Huh? Graphic cards?
CISC.
Huh? Personal computers. Old. I'm sorry. It's really old. Initial computer systems कह लो. जो initial आते थे पहले आपके command line based आते थे, graphics भी नहीं होती. आपने CLI में कमांड लिखी, वो इसको प्रोसेस करते थे, नॉट द ग्राफिक्स. एक कमांड लिखी, उसको प्रोसेस किया, फिर लिखी, उसको प्रोसेस किया. दैट्स इट, नॉट मल्टीपल. Okay, so we talked about this as well. Right, then we have is one of the most powerful one, which is multiple instructions on multiple data. Honestly speaking, the decoding of the DNA structure was done using MIMD. क्योंकि आपने इतने ज्यादा डेटा को लेना था और इतने ज्यादा प्रोसेसर्स ने उसको डिकोड करना. Okay, so supercomputers use the same architecture, multiple instructions and multiple data. Okay, इसके अलावा वैसे तो जो आपका वेदर फोरकास्टिंग वगैरह भी होता है ना, डेटा हैंडलिंग, वो भी ये यूज करता है, क्योंकि उन डेटा मॉडल्स में भी यू हैव अ लॉट ऑफ डेटा फ्रॉम अराउंड द वर्ल्ड, जिसको आप मल्टीपल प्रोसेसिंग होता है, डिफरेंट जगहों से लिया और उसको फिर प्रोसेस किया. सो वेदर फोरकास्टिंग के जो मॉडल्स होते हैं, दे आर वेरी कॉम्प्लेक्स, दे नीड टू बी प्रोसेस थ्रू सुपर कंप्यूटर्स. ओके, इसलिए याहू का और गूगल का इज वेरी एक्यूरेट, बिकॉज दे हैव अ लॉट ऑफ डेटा दैट दे प्रोसेसिंग एट द सेम टाइम. जितना डेटा होगा उतनी एक्यूरेसी बेहतर होगी, जितना कम डेटा होगा उतनी एक्यूरेसी कम होगी. यस और नो? इज डायरेक्टली प्रोपोर्शनल. Okay, so 1 second, can you listen to this? This is important. Remember, parallel processing overcomes the von Neumann bottleneck. In this type of architecture, data is constantly moving between memory and processor, fine, leading to latency. You know what latency means? The response time. Right? Okay, how much fast can you respond? Devices. Okay, how fast data is responded, उसको लेटेंसी कहते हैं. इसलिए हम कहते हैं कि 5G का जो लेटेंसी टाइम है वो बहुत कम है एज कम्पेयर टू 4G. ओके, as processor speeds have increased, the amount of time they remain idle has also increased. Since the processor performance is limited to the internal data transfer rate along the buses, finding a way around this is one of the driving forces behind parallel computing in an effort to greatly improve processor performance. Right, it was just a normal point. Okay, then you have two other concepts. You have massively parallel computers and you have clusters as well. So cluster parallel क्या होता है? Okay, right. Cluster basically जो होता है ना, it's connected through आपके पास different mainframe computers हैं and you actually join them through network lines. मगर वो independently अपना काम कर रहे हैं. Okay, okay, you want to work on a very complex code and you one computer can't do it, so you are going to create a network cluster of these pieces that would do such a kind of parallel processing. Parallel processing का मतलब ये है कि what does it mean? One particular processing being done by multiple PCs, computers, is parallel processing. अब ये cluster का मतलब होगा कि obviously they are connected to each other, being networked. ठीक है, इसी के साथ there is another one which is known as massively parallel. Massively parallel is a different form. इसमें ये नेटवर्क नहीं होते, इसमें ये होता है कि ये एक ही होता है जिसके अंदर you have multiple machines working in one unit, like the supercomputer. So supercomputer basically comes under massively. It's not clustered. Can you listen to this? Okay. This is something different to cluster computers, where each computer processor remain largely independent. Okay, we are talking about the cluster. Okay, where each computer processor remains largely independent. Agree? Because they are clusters, they are independent. In massively parallel computer, each processor will carry out part of processing and communication between computers is achieved via interconnected data paths. Okay, इसमें proper data paths होते हैं. Technically, it's embedded into one unit कहा जाता है इसको. Okay, not through network lines. One unit में रखा जाता है और उसमें connect किया जाता है, and that makes a supercomputer. Let me elaborate this. मेरा बात सुनो, मैंने इसका यहाँ निकाला भी हुआ था. Hold on. बल्कि मैं आपको इसका भी प्रिंट आउट भी दे दूंगा. ये देखो, जाफेर Isa? Okay. One application where massively parallel computers justify your choice. Weather forecasting, obviously. Fine. Okay, right? Massively आप वहाँ use कर सकते हो. Super computer massively वही use करोगे ना? Okay. मगर नहीं, मैं एक और क्वेश्चन चाह रहा था, ये तो खैर बेसिक है. हाँ, MIMD यूज होगा, एग्जैक्टली. खैर एक और था, हाँ. This is better. What is the difference between cluster? Let's see. What is the difference between cluster computers and massively computers? So cluster की अगर बात करते हैं, मैं इसको तो बुक में बहुत थोड़ा लिखा हुआ, मैं इसको थोड़ा elaborate करना चाह रहा हूँ. पहली बात तो एक scale. Let's talk about individually. Clusters are composed of multiple individual computers connected through network. Okay, these nodes obviously can be standard PC or servers. Okay, have their own power. So मैं बल्कि इसका प्रिंट आउट दे देता हूँ. On each node is typically operates on independent. डिस्कस कर लिया नेटवर्क टोपोलॉजी में, किसी में भी इंप्लीमेंट हो सकता है, इंटरकनेक्ट होता है. फाइन. अगर मैसिवली की बात करते हैं, मैसिवली पैरेलल कंप्यूटर कंसिस्ट ऑफ लार्ज नंबर प्रोसेसिंग यूनिट्स और कोर्स integrate on a single hardware platform. Get my point? Single hardware platform मतलब एक हो सकता है मदरबोर्ड की फॉर्म में हो, मगर प्रॉपर हार्डवेयर होता है, केबलिंग नहीं होती. गेट माय पॉइंट? क्योंकि केबलिंग के थ्रू तो वो उस तरह फंक्शन नहीं करेगा ना फास्ट. और बाकी इंटरकनेक्टेड, हाई स्पीड इंटरकनेक्ट अलाउ फास्टर कम्युनिकेशन और आर्किटेक्ट. फाइन. मतलब इसका प्रिंट आउट देता हूँ. और इसमें एक और क्वेश्चन था जो What is meant by von Neumann bottleneck? अभी डिस्कस किया था. What was von Neumann bottleneck? It was this. The bottleneck arises from the fact that the speed at which the CPU can process instructions is typically much faster than the speed at which data can be transferred to and from the memory. इसका मतलब क्या हुआ? Why will the bottleneck completed be there? For the speed of CPU can process instructions typically more faster than at which it would be transferred to and from the memory. This means delay is, हाँ, क्योंकि उसको डेटा मिल नहीं रहा टाइम पे. मतलब आपके जो बसेस आप कितनी एफिशिएंट नहीं है, इन ए वे आप कह लो. हार्डवेयर की प्रोसेसर इज गुड, बट मे बी जब मैंने लेक्चर शुरू किया होगा, एस लेवल में डिस्कस किया होगा, आप जब डिजाइन करते हो एक अनब्रांडेड कंप्यूटर, आप एक प्रोसेसर लेते हो, मदरबोर्ड लेते हो, हार्ड ड्राइव लेते हो, ठीक है, और उसको आप प्रॉपर्ली चेक नहीं करते. मतलब यू डोंट सीक द कंपैटिबिलिटी. कंपैटिबिलिटी मींस कि योर प्रोसेसर इज रियली वर्किंग फास्ट, your hard drive is compatible with your processor, but the bottleneck is created because सारा तो तेज काम कर रहे हैं, मगर आपके जो बसेस हैं, they cannot transfer data at the same speed. वो काम कर रहे हैं, मगर कहीं ना कहीं रुकावट है. That is known as bottleneck. There has to be a correlation in speed performance of every hardware that you're using. या वो RAM हो, या motherboard की speed हो, या वो processor की speed हो, it has to be. If you achieve this, the performance increases to a lot of extent. Yes or no? So that's what bottleneck means. Right? I hope you won't forget this. ये typical questions है. और था question, बाकी वो तो हम डिस्कस कर लिया. मैं इसका प्रिंट आउट देता हूँ आपको. ये typical questions आते हैं. मैंने कहा कितने प्रिंट आउट्स? 3.